close your eyes right now? Go ahead, do it. What do you see? Darkness, right? Or do you? Here's something that's going to shatter everything you think you know about the world around you. What you're experiencing right now might not actually exist. I'm serious. That darkness you're seeing? According to quantum physics, neuroscience, and centuries of philosophical investigation, darkness might be the most elaborate illusion your brain has ever created. It's not a thing. It's not made of particles. You can't bottle it, weigh it, or measure it directly. Darkness might be nothing more than your consciousness desperately trying to make sense of. Absolutely nothing. But here's where it gets genuinely disturbing. If darkness doesn't exist, then what are you actually experiencing when you close your eyes? What fills the universe between stars? And most unsettling of all, what does this reveal about the nature of reality itself? What if I told you that darkness is to light what silence is to sound, what cold is to heat, what death is to life? Not an opposite force, but the complete absence of something. And yet, we fear it. We fight it. We've built entire civilizations around banishing it. Why? By the end of this exploration, you're going to question whether you've ever truly understood what nothing means. You're going to discover why the absence of something can feel more powerful than the presence of anything else. And you might just realize that the darkness isn't what you should be afraid of. It's what darkness reveals about the fundamental structure of existence itself. Before we dive into this mind-bending journey, do me a favor, hit that like button and subscribe, because what I'm about to show you will change how you see the world forever. And drop a comment telling me where you're watching from and what time it is there right now. I want to know who's joining me in exploring this cosmic mystery, whether you're in Tokyo at sunrise or New York at midnight. Let's start with something that seems stupidly simple. What is light? Your elementary school teacher probably told you light is what helps you see. And technically, that's not wrong. But it's like saying the ocean is wet. It's barely scratching the surface. Light is something far stranger and more fundamental than most people realize. Light is electromagnetic radiation. It's a wave and a particle simultaneously. Yes, both at the same time, which shouldn't be possible, but absolutely is. It travels at 299,792,458 meters per second in a vacuum, and nothing in the universe can go faster. Light doesn't experience time. From a photon's perspective, the moment it's created and the moment it's absorbed happen instantaneously, even if billions of years pass for us. Think of it like this. Imagine you're on a train that's moving so fast that time itself stops. That's light's existence. Every photon that hits your eye right now has experienced 0 time since it was born, whether it came from your phone screen or from a star that died millions of years ago. Now here's the twist that starts to unravel everything. Light isn't just what allows you to see. Light is literally the medium through which electromagnetic forces operate. When you touch something, when you feel solid matter, you're actually feeling the electromagnetic repulsion between electrons in your hand and electrons in the object. Those forces? They're transmitted by photons, particles of light. So in a very real sense, you've never actually touched anything in your life. You're feeling light pushing back against you. But what happens when there's no light? This is where we need to get precise, because language is about to betray us. We use the word darkness as if it's a thing. We say, the darkness surrounds us, or darkness falls, or fighting the darkness. These phrases suggest darkness is a substance, an entity, something that exists independently and can act upon the world. But here's the revelation that changes everything. Darkness has no properties. You cannot measure darkness directly. There's no darkness particle or darkness wave. When scientists want to measure how dark something is, they're actually measuring the absence of light. They're detecting how few photons are present. In 1672, Sir Isaac Newton conducted experiments with prisms that fundamentally changed our understanding of light and darkness. He demonstrated that white light is composed of different colors, and that these colors could be separated and recombined. But his experiments revealed something even more profound. Darkness doesn't refract. Darkness doesn't interact with matter. Darkness doesn't do anything, because darkness is nothing. Let me give you an analogy that'll make this crystal clear. Think of a swimming pool. When the pool is full of water, you can measure the water's temperature, its volume, its chemical composition. The water has properties. It exists. But when you drain the pool completely, what are you measuring? You're not measuring the absence of water, as if that absence has properties. You're simply noting that water isn't there. The empty pool doesn't have anti-water in it. It has nothing. That's darkness. It's the empty pool of light. But our brains are not wired to think this way. Evolution shaped our minds to treat darkness as a real, threatening thing. For millions of years, darkness meant danger. Predators hunted in darkness. Cliffs were invisible in darkness. Fire going out meant cold and vulnerability. So our ancestors who treated darkness as a real, present threat were more likely to survive than those who shrugged and said, "Hey, it's just the absence of photons, no big deal." This creates a profound disconnect between reality and perception. Your brain insists that darkness is real because your survival once depended on that assumption. But physics tells us that darkness is as real as a hole, which is to say, a hole isn't a thing. It's the absence of material where material could be. Here's where it gets even weirder. When you close your eyes, you think you're seeing darkness. But you're not even experiencing true darkness. Your brain is generating a representation of sensory absence. The neurons in your visual cortex are firing in specific patterns that create the subjective experience of seeing nothing. But you're not seeing nothing. You're seeing your brain's interpretation of nothing. Studies by neuroscientist Carl Friston have shown that your brain is constantly making predictions about what you should be sensing, and then comparing those predictions to actual sensory input. When you close your eyes, your brain predicts zero visual input and generates a neural pattern consistent with that prediction. What you experience as darkness is actually a highly active neural computation. Think of it like this. Imagine an orchestra playing silence. The musicians aren't making sound, but they're still there, still holding their instruments, still engaged in the act of not playing. That's your visual cortex when your eyes are closed. It's not off. It's actively generating the experience of visual nothingness. This might seem like philosophical hair-splitting, but the implications are staggering. If darkness doesn't exist, then a huge portion of human culture, mythology and psychology, is built on fighting, fearing, or embracing something that isn't there. We've personified absence. We've given characteristics to nothing. We've created gods of darkness and demons of shadow, all based on a fundamental misunderstanding of what darkness actually is. Or more accurately, what it isn't. Now that we've established the basic framework, let's go deeper into the physics, because this is where things start to get genuinely mind-bending. In thermodynamics, there's a concept that parallels our discussion of darkness perfectly: cold. For centuries, scientists thought cold was a substance called frigoric that flowed from cold objects to warm ones. They were completely wrong. Cold isn't a thing. Cold is simply the absence of heat, which is molecular motion. When something feels cold, molecules are moving slowly. When something is hot, molecules are vibrating rapidly. Absolute 0 minus 273.15 degrees Celsius is the point where molecular motion theoretically stops completely. Here's what will blow your mind. Darkness is to light what absolute zero is to temperature. It's the theoretical endpoint, where the thing being measured reaches zero. But just as you can never quite reach absolute zero due to quantum effects, you can never experience true, complete darkness. Wait, what? How can that be true? Let me explain. Space, which we think of as dark, isn't actually dark. The cosmic microwave background radiation fills the entire universe with light left over from the Big Bang. It's incredibly faint, about 2.7 Kelvin in temperature, but it's there. Every cubic centimeter of space contains about 400 photons from this background radiation. The darkness of space is really just extremely dim light. In 1995, scientists created the darkest place ever made by humans, a facility at the cryogenic dark matter search experiment designed to detect dark matter particles. Even there, in a chamber shielded from all external light, cooled to near absolute zero, photons still appeared. Why? Because at quantum scales, empty space isn't empty. Virtual particles constantly pop into and out of existence. Some of these quantum fluctuations produce photons. The universe, at its most fundamental level, is never truly dark. But let's take this further. In 1900, physicist Max Planck discovered something revolutionary while trying to solve a problem called the ultraviolet catastrophe. He found that light is quantized. It comes in discrete packets called photons. You can't have half a photon or a third of a photon. Light comes in whole number units of a fundamental amount of energy. This means darkness isn't a smooth gradient from bright to dark. It's actually a stepwise function. 1 photon, 2 photons, 3 photons, and so on. The darkest possible scenario is 0 photons. But the moment you have even a single photon in the space, you no longer have darkness. You have incredibly dim light. Think of it like this. Money can't be divided infinitely. Eventually, you get down to a single penny, and you can't have half a penny in practical terms. Light works the same way. A single photon is the penny of light. 0 photons is broke. But being broke isn't the same as having negative money. There's no such thing as negative photons or anti-light in the way we think of darkness. Actually, that's not quite true, and here's where physics gets deliciously complicated. There is something called squeezed light in quantum mechanics, where you can create states that have less fluctuation than a vacuum state. In some precise quantum mechanical sense, you can create regions that are darker than darkness, darker than having 0 photons on average. But this doesn't mean darkness exists as a thing. It means the quantum properties of light are even stranger than we thought. In 2014, physicists at the University of Sydney created the darkest human-made material ever. A substance so dark it absorbs 99.965% of visible light. But even this material isn't experiencing true darkness on its surface. The absorbed photons are being converted to heat and other forms of energy. The darkness we perceive is actually violent interaction between photons and material, not the absence of interaction. Let's connect this to something you experience every day. When you walk into a dark room, your eyes adapt. Your pupils dilate, letting in more light. Special cells in your retina called rods become more sensitive. After about 30 minutes, your eyes can be up to 100,000 times more sensitive to light than they were in bright conditions. What's happening? You're not seeing darkness better. You're detecting incredibly faint light that was there all along, but was beneath your detection threshold. This is crucial. The experience of darkness is always relative to your detection capabilities and the amount of light you've recently experienced. There's no absolute darkness you can point to and say, there, that's pure darkness. It's always dimmer than, or fewer photons than something else. Physicist Richard Feynman once said, "The theory of quantum electrodynamics describes nature as absurd from the point of view of common sense, and it fully agrees with experiment. So I hope you can accept nature as she is absurd. Darkness is part of this absurdity. Common sense tells you it's real and tangible. Physics tells you it's the absence of something real and tangible. Both perspectives are describing the same reality, but from opposite directions. Here's a question that's going to haunt you. If darkness is just the absence of light, and light is electromagnetic radiation, Then is darkness simply the absence of electromagnetic interaction in the visible spectrum? What about all the other electromagnetic radiation we can't see? Radio waves, microwaves, infrared, ultraviolet, X-rays, gamma rays. When you're sitting in a dark room, you're actually bathed in electromagnetic radiation from all these sources. Your Wi-Fi router is flooding the room with microwave photons. Your body is emitting infrared radiation. Cosmic rays from space are penetrating the walls. By this measure, true electromagnetic darkness would require being in a perfectly shielded chamber with no electromagnetic radiation of any frequency. Such a place has never existed naturally anywhere in the universe since the Big Bang. So when we ask, does darkness exist? We have to specify. Darkness in which part of the electromagnetic spectrum? Visible light darkness? All electromagnetic radiation darkness? These are profoundly different questions with different answers. Now let's turn from physics to neuroscience, because how your brain processes the absence of light is just as fascinating and just as strange as the physics itself. Your visual system is arguably the most complex information processing system in your body. About 30% of your brain's cortex is devoted to processing visual information, compared to just 8% for touch and 3% for hearing. Your retinas contain about 126 million light-detecting cells, and your optic nerves carry roughly 1 million nerve fibers each. All of this computational power evolved for one primary purpose: to detect and interpret photons. But here's where it gets weird. Your brain doesn't have direct access to the external world. It sits in complete darkness inside your skull, receiving only electrical and chemical signals from your sensory organs. The vivid, colorful, three-dimensional world you experience is entirely constructed by neural computation. You're not experiencing reality directly. You're experiencing your brain's best guess about reality based on incoming data. Neuroscientist Donald Hoffman at UC Irvine has proposed something called interface theory of perception, which suggests that our perceptions are like a desktop interface on a computer. The icons on your screen don't look like the actual code and hardware processes happening inside the computer. They're simplified representations designed for user interaction. Similarly, your perception of light and darkness might be a simplified interface that helps you navigate the world, not an accurate representation of underlying reality. When no photons enter your eyes, what happens in your brain? First, let's understand how vision normally works. Photons hit photoreceptor cells in your retina rods and cones. Think of it like this. Imagine you're at a concert and everyone is shouting constantly. It's exhausting. But if everyone is quiet and someone suddenly speaks, you notice immediately. Your photoreceptors work on the quiet default principle. They're naturally active, and light causes them to quiet down. Your brain interprets patterns of quieting as visual information. This means darkness is your visual system's default state. Light is the interruption. This might seem backwards, but it's incredibly energy efficient and sensitive. In 2019, researchers at the University of Basel discovered something remarkable. Neurons in the visual cortex don't just become inactive when you close your eyes. Instead, they enter a different pattern of activity, a synchronized oscillation that doesn't occur during normal vision. Your brain actively generates the experience of darkness using coordinated neural rhythms. They found that these darkness rhythms help maintain the visual system's readiness to process light when it returns. It's like a runner bouncing on their toes before a race starts. The visual system doesn't shut off in darkness. It enters a preparatory state. But there's something even more unsettling. Your brain hallucinates constantly, even in normal vision. About 80% of the information in your visual cortex comes not from your eyes, but from other parts of your brain. Your brain is constantly predicting what it expects to see based on past experience, and then checking whether incoming sensory data matches those predictions. When you close your eyes and experience darkness, You're experiencing your brain's prediction of what no visual input should feel like, but it's still a prediction, still a construct, still a hallucination of sorts. People who lose their vision don't always experience darkness. Some experience Charles Bonnet syndrome, where their visual cortex, starved of input, begins generating complex hallucinations, faces, landscapes, patterns. Their brains refuse to accept the absence of vision and instead create elaborate visual experiences from nothing. This reveals something profound. Darkness isn't a neutral state. It's a specific neural configuration that your brain must actively maintain. Dr. V.S. Ramachandran at UC San Diego has studied phantom limb syndrome, where people who've lost limbs still feel them vividly. He suggested that vision works similarly. When you close your eyes, you might be experiencing phantom vision, the neural echo of having a visual field, even when no light is present. Let me give you an analogy that makes this clearer. Imagine you're listening to music through headphones. When the music stops, you don't hear anti-music or negative sound. You hear silence. But that silence is being processed by your auditory system, which remains active. Your brain knows the music stopped because it's still listening. Similarly, your visual cortex knows light is absent because it's still watching for light that isn't there. Here's an experiment you can try right now that will blow your mind. Close your eyes and pay attention to the darkness you see. Notice that it's not uniform. You might see swirling patterns, spots of lighter and darker areas, maybe flashes of color. These are called phosphenes visual sensations, caused by activity in your visual system itself, not by external light. Some phosphenes come from random firing of neurons. Others come from pressure on your eyeball. Still others come from the quantum noise in your retina literally, the randomness of biology at the molecular level creating false light signals. This means when you experience complete darkness, you're actually experiencing random neural noise interpreted as visual sensation. You've never experienced true perceptual nothingness. Your brain won't allow it. Brain imaging studies using fMRI have shown that when people are placed in complete darkness, their visual cortex doesn't deactivate. Instead, it begins communicating more with other brain regions, memory centers, emotional centers, self-referential thinking areas. Darkness causes your brain to turn inward. This might explain why sensory deprivation prolonged darkness combined with silence can cause profound psychological effects. Volunteers in sensory deprivation experiments often report hallucinations within hours, transcendent experiences, and altered states of consciousness. When external input drops to near zero, your brain fills the void with internally generated content. The absence of something doesn't create emptiness in consciousness. It creates an opportunity for consciousness to fill itself with itself. Let's descend into the quantum realm, where the distinction between light existing and not existing becomes genuinely bizarre. At the quantum scale, the universe operates according to rules that violate everything your intuition tells you about how reality should work. And nowhere is this more apparent than in the behavior of light. In 1801, Thomas Young performed the famous double-slit experiment. He shone light through two narrow slits and observed an interference pattern on a screen behind them, proof that light behaves as a wave. But here's where it gets strange. When you send individual photons one at a time through the slits, they still create an interference pattern over time. Each photon somehow knows about both slits and interferes with itself. But if you try to observe which slit a photon goes through, the interference pattern disappears. The act of observation changes the outcome. The photon behaves like a particle when observed, and like a wave when not observed. Now, what does this have to do with darkness? Everything. When you observe a region of space to determine if a photon is there, you're making a quantum measurement. Before you observe, the photon exists in a superposition, a state where it's simultaneously present and absent, here and there, existent and non-existent. Only when you measure does it collapse into a definite state. Think of it like this. Imagine you have a coin spinning in the air. While it's spinning, it's neither heads nor tails. It's both and neither. Only when it lands and you look does it become definite. Photons exist in this spinning state until observed. This means darkness, at the quantum level, isn't simply the absence of photons. It's a quantum state, the vacuum state, which has its own properties and behaviors. In 1948, Dutch physicist Hendrik Casimir predicted something remarkable. If you place two metal plates extremely close together in a vacuum, they'll attract each other, even though there's nothing between them. This Casimir effect was experimentally confirmed in 1997. But how can nothing create a force? The answer is that quantum vacuum isn't empty. It's seething with virtual particles, particle-antiparticle pairs that pop into existence for infinitesimal fractions of a second before annihilating each other. These quantum fluctuations are real enough to create measurable forces. In complete darkness, zero real photons, virtual photons, are still appearing and disappearing constantly. The darkness has energy and structure at the quantum level. Physicist Paul Davies has calculated that if you could extract all the vacuum energy from a volume the size of a coffee cup, it would contain enough energy to boil all the world's oceans. That's how much something exists in nothing. Let's go even deeper. In quantum field theory, light is described as excitations in the electromagnetic field. The electromagnetic field permeates all of space at all times. A photon is like a ripple on a pond. The water was always there, but now there's a wave moving through it. Darkness, then, is the electromagnetic field in its ground state, no ripples, no excitations, but the field itself still exists. You can't have darkness without the electromagnetic field being present. In this view, darkness is not absence. It's the substrate, the foundation, the canvas on which light is painted. Here's where your brain should start hurting. If the electromagnetic field is everywhere always, then there's no such thing as a place without light potential. Darkness is just unactualized light potential. Every point in space is ready to be light at any moment. In 2011, researchers at Chalmers University in Sweden experimentally demonstrated that you can create photons from the vacuum. They built a device with a mirror that moves at nearly the speed of light. According to quantum mechanics, this mirror disturbs the vacuum enough to convert virtual photons into real photons, creating light from darkness. They literally created light from nothing, or more accurately, from the quantum fluctuations that exist in nothing. This raises a philosophical question that sounds like a Zen koan. If the potential for light always exists, and virtual photons are constantly flickering in and out of existence, is darkness ever really dark? Let's connect this to a concept from quantum information theory: entropy. In physics, entropy measures disorder or randomness. The second law of thermodynamics states that entropy always increases in closed systems. Things tend toward disorder. Light carries information. When you see something, photons carrying information about that object enter your eye. Darkness, by contrast, carries no information. It's maximum entropy for the visual system. You can learn nothing from true darkness. But here's the twist. Quantum mechanically, a perfect vacuum state is actually a state of minimum entropy, not maxima. It's perfectly ordered. There's nothing there to be disordered. This creates a paradox. Classically, darkness is disorder, maximum entropy. Quantum mechanically, darkness is perfect order, minimum entropy. Reality operates on the quantum mechanical description. This means that darkness is actually the most ordered state possible, and light, with all its information and structure, is a departure from perfect order into relative disorder. This completely inverts how we think about light and darkness. Light isn't order brought to chaos. Light is organized chaos emerging from perfect emptiness. Physicist Sean Carroll has pointed out that the arrow of time, the reason why time flows forward, is fundamentally connected to entropy increase. The universe started in a very low entropy state at the Big Bang and has been increasing in entropy ever since. But the Big Bang was also the moment when the entire universe was filled with light, a cosmic microwave background radiation. As the universe expanded and cooled, this light dimmed and spread out. Darkness is, in a very real sense, the destination of the universe. The ultimate fate of the cosmos, according to current cosmology, is heat death, a state where the universe has expanded so much that all light has redshifted into invisibility, all stars have died, and only darkness remains. But even that darkness will contain the vacuum energy, the quantum fluctuations, the electromagnetic field in its ground state. The universe can never be truly empty. Here's what will really blow your mind. Some interpretations of quantum mechanics suggest that observation creates reality. Before measurement, particles exist in superposition. Only measurement collapses the wave function into a definite state. If this is true, and it's hotly debated, then unobserved darkness might not have any definite properties at all. A dark room, when no one is looking, might exist in a quantum superposition of having various numbers of virtual photons, various configurations of the electromagnetic field. Only when you open the door and look does it become definitely dark or dimly lit. Darkness might not exist in any meaningful sense when no one is there to experience it. Mathematics gives us a precise language for describing light and darkness. And when we look at the equations, something beautiful and strange emerges. The fundamental equation describing light is Maxwell's equations, formulated by James Clerk Maxwell in 1865. These four elegant mathematical statements unify electricity, magnetism, and light into a single theory. They describe how electric and magnetic fields generate each other, creating waves that propagate through space at the speed of light. Here's what's remarkable. Maxwell's equations have a solution where electric and magnetic fields are both zero everywhere. This is the mathematical description of complete darkness. But look carefully at what this means. Darkness is not the absence of equations or the absence of fields. It's a specific solution where the field values happen to be zero. Think of it like this. Imagine you have an equation describing the height of ocean waves. Calm, flat water, no waves, is still a solution to the equation. It's the solution where wave height equals zero. Similarly, darkness is the solution to Maxwell's equations where field strength equals zero. Darkness is mathematically defined, not mathematically absent. In 1905, Albert Einstein explained the photoelectric effect, how light can knock electrons out of metal. This was revolutionary because it required light to behave as particles, photons, not just waves. Einstein's equation was simple. E equals hf, where E is energy, h is Planck's constant, and f is frequency. This equation has profound implications for darkness. If there are zero photons, then E equals zero, zero energy. But notice that frequency still exists as a variable in the equation. You can have zero photons of red light, zero photons of blue light, zero photons of X-rays. Darkness has a frequency structure. It's not all the same. Imagine silence in music. The silence between notes has different qualities depending on what note you're not hearing. A C note silence feels different from a G note silence to musicians, even though acoustically they're identical. Similarly, darkness has a spectral structure, which frequencies of light are absent matters, even though they're all equally absent. Let's go deeper into the mathematics. In quantum field theory, the state of the electromagnetic field is described by something called a Fock state, which counts the number of photons present. The vacuum state is written as 0, 0 photons. But this state has mathematical properties. You can perform operations on it, transform it, measure its energy, which turns out to be infinite, leading to the famous vacuum catastrophe problem in physics. The mathematical existence of the vacuum state means darkness is not nothing. It's a something with zero of a specific quantity. Here's an analogy. Zero is a number. It's not the absence of number. It's a specific number that represents absence. When ancient mathematicians invented zero, it was revolutionary precisely because it gave mathematical existence to nothingness. Darkness is the zero of light, a specific state that represents absence. In information theory, developed by Claude Shannon in 1948, information is measured in bits. 1 bit is the answer to a yes, no question. Light carries information, its wavelength, intensity, polarization, phase. Darkness carries 0 bits of information in the visual spectrum. But here's where it gets interesting. 0 information is itself information. If I tell you there is no light, I've communicated something meaningful to you. The absence is informative. This is called negative information in some contexts, and it's crucially important. Scientists use a concept called signal-to-noise ratio. In complete darkness, there's 0 signal, but quantum noise still exists. The information in darkness is that the signal-to-noise ratio is 0. You're measuring pure noise. But noise itself carries information about the system that generates it. Let's connect this to probability theory. Imagine you're trying to predict whether a photon will be present in a region of space. If the region is dark, the probability is 0. But 0 probability is a specific, meaningful probability. It's different from unknown probability or undefined probability. Mathematician and physicist Roger Penrose has explored the geometry of light through something called twistor theory. In this framework, light rays are the fundamental objects, and space-time emerges from relationships between light rays. Darkness, in twistor theory, would be the absence of twistors, a region where the fundamental structure of space-time exists, but is not activated. This suggests that space-time itself can exist without light, but light cannot exist without space-time. Darkness is the background condition of existence itself. Here's a mind-bending mathematical fact. In general relativity, light follows paths called null geodesics, trajectories through space-time that have 0 length. That's right from the perspective of relativity. The path a photon takes from a star to your eye has literally 0 distance and 0 duration. Light exists on the boundary between space and time, connecting distant points with 0 separation. Darkness, then, is the absence of these 0-length connections. It's a state where distant points remain distant, where the universe is disconnected. Let me give you one more mathematical perspective that will reshape how you think about this. In topology, the mathematics of shape and space, there's a concept called compactness. A compact space is one where you can't have an infinite sequence of points without some of them clustering together. Light makes space compact in a sense. Now let's zoom out to the largest scales possible and ask, what role does darkness play in the universe as a whole? The universe began 13.8 billion years ago in the Big Bang. At the very earliest moments, the first fractions of a second, the universe was incredibly hot and dense. So hot that matter as we know it couldn't exist. So dense that photons couldn't travel freely. But here's the thing, there was no darkness. For the first 380,000 years of the universe's existence, it was completely opaque. Photons bounced around constantly, scattered by free electrons. You couldn't see through it, but not because it was dark. It was like being inside a star. Everywhere you looked would have been blinding light. Then came a moment called recombination, when the universe cooled enough for electrons and protons to combine into hydrogen atoms. Suddenly, photons could travel freely. The universe became transparent. This is the moment the cosmic microwave background radiation was released, the afterglow of the Big Bang that we can still detect today. For the first time, darkness became possible, but even then, the universe wasn't dark. It was filled with this background glow. Astronomer Olber's paradox, formulated by Heinrich Wilhelm Olbers in 1823, asks a simple question. If the universe is infinite and filled with stars, why is the night sky dark? Every line of sight should eventually hit a star, making the entire sky as bright as the sun's surface. The resolution to this paradox is that the universe is not infinite in age. Light from distant stars hasn't had time to reach us yet. The universe is expanding, redshifting distant light beyond visibility. And most importantly, there's vastly more empty space than stars. Darkness exists because the universe is finite in age and expanding. In a static, infinite, eternal universe, there would be no darkness. Here's where cosmology gets seriously weird. Modern observations show that ordinary matter atoms, stars, planets, people makes up only about 5% of the universe's energy content. About 27% is dark matter, invisible matter that doesn't emit light but does have gravity. And about 68% is dark energy, a mysterious force causing the universe's expansion to accelerate. Both are called dark because they don't interact with light. But they're not darkness in the sense we've been discussing. Dark matter isn't the absence of light. It's matter that happens to be invisible. Dark energy isn't the absence of light. It's a form of energy that fills space. The naming is actually unfortunate because it confuses the concept. The universe isn't 95% dark. It's 95% filled with things we can't see with light. There's a difference. Astrophysicist Neil deGrasse Tyson has pointed out that if dark matter and dark energy were visible, the night sky would be blazing with light. The darkness of space is partly due to the limitations of our light-detecting instruments, not to actual absence. Let's talk about black holes, the darkest objects in the universe. Black holes have gravity so strong that light cannot escape from within their event horizon. They're called black because they don't emit light, or they emit only tiny amounts of Hawking radiation, which is almost impossible to detect. But here's the fascinating thing. Black holes aren't examples of darkness in our philosophical sense. They're not regions where light is absent. They're regions where light is trapped. Photons are falling into the black hole constantly from the surrounding space. Inside the event horizon, light still exists. It's just moving toward the singularity and can't escape. Stephen Hawking's work on black holes revealed that they do emit radiation, now called Hawking radiation. This radiation is caused by quantum effects at the event horizon, where virtual particle pairs separate, with one particle escaping and one falling in. Black holes glow, incredibly faintly, from quantum processes in the darkness surrounding them. Even the darkest objects in the universe aren't truly dark. Let's consider what astronomers call the dark ages of the universe. After the cosmic microwave background was released, but before the first stars formed, roughly from 380,000 years to 150 million years after the Big Bang, the universe was truly dark. No stars, no galaxies, just expanding hydrogen gas slowly cooling in the darkness. But even then, the cosmic microwave background radiation was present, just redshifted into longer wavelengths. The universe was dark in visible light, but glowing in infrared. And on the quantum level, the vacuum energy was still there. Virtual particles were still fluctuating. The darkest period in cosmic history still wasn't completely dark. Here's something that will give you chills. The universe is getting darker over time. Due to cosmic expansion, galaxies are moving apart. In a few trillion years, galaxies will be so far apart that no light from distant galaxies will be able to reach any given galaxy. Future civilizations will look at their night sky and see only their own galaxy surrounded by complete darkness. They'll think they're alone in the universe, not because they are, but because light from other galaxies will have been stretched into invisibility by expansion. Darkness will hide the truth of cosmic existence from them. Cosmologist Lawrence Krauss has written about how future astronomers in this dark cosmos won't be able to discover the Big Bang, cosmic expansion, or the true nature of the universe. Darkness will make the truth unknowable. But even that far future darkness will still contain the cosmic microwave background, though incredibly redshifted, vacuum energy, and quantum fluctuations. The universe can't escape its own quantum substrate. Now here's the ultimate cosmic question. What happens at the end? Current cosmology suggests several possible fates for the universe. The most likely, given our observations of accelerating expansion, is heat death or the big freeze. The universe will continue expanding forever. Stars will burn out. Black holes will evaporate by Hawking radiation. And eventually, everything will decay into a thin soup of photons, neutrinos, and perhaps stable particles like electrons and positrons separated by vast distances. This final state is sometimes called maximum entropy, complete disorder, and it's dark. No stars, no light sources, just darkness. But even here, quantum mechanics intrudes. In an infinitely long timeline, quantum fluctuations become significant. Given enough time, unimaginably vast amounts of time-random quantum fluctuations could spontaneously create structures. A star could randomly assemble from particles that happen to be in the right place. A new Big Bang could randomly nucleate from vacuum fluctuations. Physicist Sean Carroll has suggested that given infinite time, anything that can happen will happen, including the spontaneous creation of entire universes. Darkness, given eternity, will eventually give birth to light again, somewhere, somehow. The darkness isn't the end. It's a pause between cycles. There's a beautiful symmetry here. The universe began with light. The hot, dense plasma of the early universe will end in darkness, heat death. But that darkness contains the seeds of future light, quantum fluctuations that could create new universes. Alpha and Omega, beginning and end, light and darkness. They're not opposites, they're phases in a cosmic cycle. Let me give you one final cosmological perspective that ties this all together. The observable universe, the region of space from which light has had time to reach us since the Big Bang, is about 93 billion light years in diameter. Beyond that is ... what? We don't know. Light from beyond that boundary hasn't reached us yet. It's dark to us not because it lacks light, but because we're separated from it by cosmic expansion in finite time. That darkness is informational, not physical. The light exists. We just can't access it yet. This means most of the universe is dark to us, but not dark in itself. Darkness is perspective dependent. An alien civilization 50 billion light years away sees light from regions we perceive as dark and perceives as dark regions we can see. Darkness isn't a property of space itself. It's a property of the relationship between an observer and distant space. Cosmology reveals that darkness is about limits, the limit of observation, the limit of causal connection, the limit of time, the limit of expansion. Darkness marks the boundaries of what we can know and experience. Now let's shift from physics and cosmology to the human mind and culture. Why do we fear darkness? Why do we personify it? Why does something that doesn't exist have such psychological power over us? The answer starts with evolution. For millions of years, our ancestors lived in a world where darkness was deadly. Predators with better night vision hunted in darkness. Environmental hazards like cliffs and rivers were invisible in darkness. Fire going out meant cold, vulnerability, and danger. Natural selection ruthlessly favored individuals who treated darkness as threatening. Those who were relaxed about darkness were more likely to die before reproducing. Those who were vigilant, fearful, and careful in darkness passed their genes on. Psychologist R.J. Stevenson conducted studies in 2011 showing that humans have an innate fear response to darkness that appears as early as age 2 without any negative conditioning. Children who've never experienced anything bad in darkness still show fear of it. This fear is hardwired. But here's what's fascinating. We're not really afraid of darkness itself. We're afraid of what might be hidden in darkness. Darkness represents uncertainty, the unknown, the inability to gather visual information. It's the epistemic void that terrifies us, not the absence of photons. Think of it like this. Imagine you're in a completely dark room. Are you afraid of the darkness? Or are you afraid of what might be in the room with you? The moment I tell you, you're alone. The room is empty. There's nothing to harm you. The fear diminishes dramatically, even though the physical darkness is unchanged. Darkness is frightening because it forces us to confront how dependent we are on vision. About 80% of the sensory information your brain uses to construct your model of reality comes from vision. When that input disappears, you become drastically less certain about your surroundings. Neuroscientist Carl Friston's free energy principle suggests that the brain's fundamental imperative is to minimize uncertainty about the world. Darkness maximizes uncertainty. Therefore, darkness is cognitively intolerable to the brain, triggering stress responses designed to motivate escape from uncertainty. We don't fear darkness. We fear uncertainty. But humans have a strange relationship with darkness that goes beyond fear. We're also drawn to it. We associate darkness with sleep, rest, intimacy, mystery, and the sacred. Nearly every religious tradition has rituals involving darkness or performed at night. Psychologist Carl Jung wrote about the shadow, the dark aspects of personality that we repress or deny. Jung argued that integrating the shadow is essential for psychological wholeness. The metaphor is no accident. We project our psychological darkness onto physical darkness, and working with actual darkness becomes a way to work with psychological darkness. In cultures worldwide, darkness is associated with death, evil, ignorance, and danger. Light is associated with life, goodness, knowledge, and safety. These associations are so deep that they pervade language itself. We say, dark deeds and shining examples, enlightenment and being in the dark, seeing the light and dark times. But anthropologist David Abram has pointed out that this light good, darkness bad dichotomy isn't universal. Some indigenous cultures view darkness as nurturing, as the womb from which life emerges, as a necessary counterpart to light rather than its enemy. The Tao Te Ching, written in ancient China, describes the Tao as emerging from darkness. The Tao that can be told is not the eternal Tao. Darkness within darkness, the gateway to all understanding. In this view, darkness isn't the absence of something good. It's the presence of something profound, mystery, potential, the ground of being itself. Modern industrial society has an unprecedented relationship with darkness. We're trying to eliminate it entirely. Light pollution is so extensive that 80% of humans now live under light-polluted skies. In major cities, genuine darkness no longer exists at night. The ecological consequences are staggering. Nocturnal animals are disrupted. Migrating birds become disoriented. Insects are drawn to lights and die by the billions. Human circadian rhythms are disturbed, leading to sleep disorders and health problems. We're conducting an unprecedented experiment. What happens to life when darkness disappears? Quantobiologist Till Roenberg has studied how artificial light affects human biology. Exposure to light at night suppresses melatonin production, disrupts circadian rhythms, and is associated with increased rates of obesity, diabetes, depression, and certain cancers. Our bodies evolved expecting darkness at night, and we're suffering the consequences of eliminating it. But perhaps most profound is what we're losing psychologically and spiritually. Philosopher David E. Nye wrote about the technological sublime, the awe inspired by human achievements. Electric light is perhaps our most successful technology. We've conquered darkness. Or have we? What if eliminating darkness isn't a triumph, but a loss? What if we need darkness, not just biologically, but psychologically and spiritually? Psychotherapist Clark Strand wrote a book called Waking Up to the Dark, where he argues that our elimination of darkness has eliminated an essential part of human experience. In darkness, the ego relaxes. The constant visual stimulation that reinforces our sense of self diminishes. We become more receptive, more contemplative, more connected to something larger than ourselves. Many spiritual traditions use darkness deliberately. Christian monks practice dark retreats, extended periods in complete darkness for prayer and meditation. Tibetan Buddhism has a practice called dark retreat, lasting days or weeks in total darkness to facilitate advanced meditative states. In darkness, something happens to consciousness. Without visual input dominating awareness, other modes of perception emerge. Inner vision, intuition, a sense of presence, these become more accessible. Perhaps darkness isn't something to conquer, but something to inhabit. Not as a place of fear, but as a place of transformation. Let's go even deeper now into the philosophical implications. If darkness doesn't exist as a thing, what does this tell us about existence itself? Philosophers have grappled with the concept of non-being for millennia. Parmenides, an ancient Greek philosopher from around 500 BCE, argued that non-being cannot exist. His reasoning was simple but profound. If something doesn't exist, then it is not, and therefore there's nothing to talk about. You cannot speak meaningfully about what isn't. This creates a paradox. When we say, darkness doesn't exist, we seem to be saying something meaningful about darkness. But if it doesn't exist, how can we say anything about it at all? Medieval philosophers called this the problem of negative predication, how we can make true statements about absences. Thomas Aquinas argued that we can discuss absences by reference to what's absent. Darkness is meaningful because it refers to the absence of light, which does exist. Think of it like this. A hole in your sock is not a thing. It's the absence of fabric where fabric should be. But you can meaningfully say, there's a hole in my sock, because you're referencing the sock and the absence within it. The hole is a dependent absence. It depends on the surrounding fabric to have any meaning. Darkness is a dependent absence. It only has meaning in reference to light. But philosopher Martin Heidegger took this further. He argued that Western philosophy has been obsessed with beings, things that exist, and has ignored being itself, the ground of existence. In his view, we need to pay attention to the nothing, not as mere absence, but as a positive phenomenon in its own right. Existential anxiety, not fear of specific things, confronts us with the nothing. In anxiety, the familiar world of objects and meanings dissolves, and we're left facing the sheer fact that we exist at all, suspended over an abyss of non-being. Darkness, in this view, is a manifestation of the nothing. When we're in darkness, we lose our usual relationship with the world of visible objects. We're confronted with the groundlessness of existence itself. Eastern philosophy offers a different perspective. In Buddhism, emptiness, anatta, is a central concept. But emptiness doesn't mean nothingness. It means the absence of inherent, independent existence. Everything exists in dependence on other things. Nothing exists purely in itself. Light depends on sources, media, and observers. Darkness depends on the absence of light sources. Both are empty of independent existence. Both are interdependent phenomena. The Heart Sutra, a central Buddhist text, says, "Form is emptiness, emptiness is form." Applied to our question, light is darkness, darkness is light. They're not opposites, but interdependent aspects of a unified whole. Let's explore another philosophical angle, the problem of perception versus reality. John Locke, in the 17th century, distinguished between primary qualities, properties that objects really have, like extension and motion, and secondary qualities, properties that depend on perception, like color and taste. Is darkness a primary or secondary quality? Physics tells us darkness is not a primary quality. There's no darkness out there in objective reality, just varying amounts of electromagnetic radiation. But experientially, darkness is absolutely real. You experience it vividly. This suggests darkness is a secondary quality. It exists in the relationship between the world and the perceiver, not in the world itself. But philosopher Thomas Nagel argued that subjective experience is irreducible to physical description. In his famous essay, "What is it like to be a bat?" he argued that consciousness has a subjective character that can't be captured by objective science. The experience of darkness is real, even if darkness isn't real in the physical sense. Your experience has ontological status existence, even if what you're experiencing doesn't. This creates a strange double reality. Darkness doesn't exist physically, but does exist experientially. Philosopher Ludwig Wittgenstein said, "The limits of my language mean the limits of my world." Our language treats darkness as a thing, and this shapes how we think about it. If we didn't have the word darkness, if we could only say absence of light, would we think about it differently? Some languages do handle this differently. In Hopi, a Native American language, temporal concepts are structured very differently from English. Time isn't a thing that flows. It's a relationship between events. Perhaps speakers of Hopi-like languages would naturally think of darkness as a relationship rather than a thing. Language shapes thought, and thought shapes reality as we experience it. Let's consider the philosophical concept of privation, the absence of something that should be present. Blindness is a privation of sight. Silence is a privation of sound. Is darkness a privation of light? Augustine of Hippo argued that evil is a privation of good. It's not a positive force, but the absence of goodness. This privation theory of evil has been influential in Christian theology. If we apply this to darkness, we might say, darkness is not an evil force opposing light. It's simply what remains when light is absent. The battle between light and darkness isn't a battle between two forces. It's the spreading or withholding of one force. But this raises a troubling question. If darkness is mere absence, why does it feel so powerful? Why do we experience it as active, threatening, almost alive? Phenomenologist Maurice Merleau-Ponty argued that perception isn't passive reception of data. It's active engagement with the world. When we're in darkness, we don't just passively fail to receive visual data. We actively reach out with our perception and encounter ... nothing. The collision between active perception and perceptual nothingness creates the vivid experience of darkness. It's like expecting to shake someone's hand and finding nothing there. The absence is shocking precisely because you are prepared for presence. Here's a thought experiment that philosophers call a modal question, a question about possibility. Could there be a universe where darkness is the default and light is the intrusion? Where the laws of physics make darkness the energetic state and light requires energy to suppress? Actually, in a sense, our universe is like this. The vacuum state darkness is the ground state, the lowest energy configuration. Adding photons requires energy. Light is the intrusion into darkness, not vice versa. This inverts our usual intuition. We think light is natural, and darkness is what happens when light is removed. But physically, darkness is the default, and light is what happens when energy is added to the system. Now, let's explore how humanity has used darkness metaphorically and symbolically throughout our cultural history, because this reveals something profound about how we make meaning from absence. In Western mythology, darkness is almost universally associated with chaos, evil, and the unknown. The book of Genesis begins, "In the beginning, darkness was upon the face of the deep." Darkness precedes creation. It's the primordial state before God creates light and order. Norse mythology has Ginnungagap, the yawning void of darkness that existed before the cosmos. Greek mythology begins with chaos, a dark abyss from which everything emerges. Darkness is the womb of creation in these traditions. But darkness is also where things return at death. The Greek underworld Hades is beneath the earth in eternal darkness. The Egyptian Duat, the realm of the dead, is described as dark. Sheol in Hebrew tradition is a dark place of shades and shadows. Darkness is both origin and ending, the Alpha and Omega. Joseph Campbell, the great mythologist, identified the hero's journey as a common pattern in myths worldwide. One recurring phase is descent into darkness literally or metaphorically. The hero must go into the cave, the underworld, the dark forest. There, they face trials and emerge transformed. Christ descends to hell before resurrection. Inanna descends to the underworld and returns. Odysseus visits Hades. Dante journeys through the inferno. The pattern repeats because it represents psychological truth. Transformation requires confronting what we've hidden in darkness. In literature, darkness becomes incredibly rich as a symbol. Consider Joseph Conrad's Heart of Darkness, where the African interior represents the darkness within European colonialism and the human soul itself. The darkness isn't just physical, it's moral, psychological, existential. Or consider how Shakespeare uses darkness in Macbeth. The murder happens at night. Lady Macbeth says, "Come, thick night, and pall thee in the dunnest smoke of hell." Darkness enables evil by hiding it, but darkness also symbolizes the moral darkness descending on the characters. Yet Shakespeare also uses darkness for intimacy and love. Romeo and Juliet meet at night. Their famous balcony scene happens in darkness. Darkness here enables honesty, vulnerability, connection, things too risky in the light of day. Artist Caravaggio revolutionized painting in the early 1600s with his use of tenebrism, dramatic contrasts between light and dark. His paintings place figures in almost complete darkness with stark illumination, highlighting faces and hands. The darkness isn't just background. It's an active force that makes the light meaningful. Without darkness, light is just uniform brightness. Darkness gives light shape, definition, purpose. Photographer Ansel Adams said, "You don't take a photograph, you make it." His mastery of light and shadow in black and white photography showed that darkness isn't the enemy of visual art, it's the partner. Every photograph is a sculpture of light and darkness. In music, darkness finds expression in minor keys, dissonance, silence. Composer John Cage's famous piece, 433, is 4 minutes and 33 seconds of silence. The performer sits at the piano and plays nothing. What the audience hears is ambient sound coughs, rustling, air conditioning framed by silence. Cage said, "There is no such thing as silence. Something is always happening that makes a sound. Similarly, there is no such thing as darkness. Something is always present, even if it's just quantum fluctuations. The silence makes the ambient sound audible. The darkness makes the faint light visible." Gothic literature is built on darkness, both literal and metaphorical. Think of Dracula, Frankenstein, The Strange Case of Dr. Jekyll and Mr. Hyde. These stories use darkness to explore the shadow side of humanity, the parts we hide even from ourselves. But in these stories, darkness often reveals truth. Frankenstein's monster is hideous in appearance, but philosophically profound. Hyde is evil, but represents suppressed desires that Victorian society pretended didn't exist. Darkness doesn't lie, light does, by showing only surfaces. Poetry has a special relationship with darkness, because poetry tries to express the inexpressible. Rainer Maria Rilke wrote, "I live my life in widening circles that reach out across the world. I may not ever complete the last one, but I give myself to it." The widening circles move from light into darkness, from known into unknown. The poet embraces this movement. Darkness isn't failure to understand, it's the invitation to explore. Or consider these lines from T.S. Eliot's East Coker. "I said to my soul, be still, and let the dark come upon you, which shall be the darkness of God, darkness as divine, darkness as revelation." This is mystical literature, where darkness is the cloud of unknowing, the dark night of the soul, necessary stages in spiritual awakening. In Japanese aesthetics, there's a concept called Yu-jana profound, mysterious sense of beauty in darkness and shadows. Traditional Japanese architecture uses paper screens that diffuse light, creating graduated shadows rather than stark contrasts. The aesthetic celebrates what's half seen, suggested, hidden. Junichiro Tanizaki wrote an essay called In Praise of Shadows, where he argues that Western culture's embrace of bright, uniform lighting destroys beauty. True beauty, he claims, exists in the interplay of light and shadow, in what's concealed as much as what's revealed. Were it not for shadows, there would be no beauty. Modern and postmodern art have explored darkness in radical ways. Mark Rothko's late paintings are almost entirely dark, deep burgundies, browns, blacks. They're massive canvases that seem to absorb light. Standing before them, viewers often report profound emotional experiences. Some find them depressing, others transcendent. Rothko said, "The people who weep before my pictures are having the same religious experience I had when I painted them." The darkness in his paintings isn't about anything. It's pure experience of darkness as such. Installation artist James Torrell creates sky spaces rooms with openings in the ceiling framing the sky. As day transitions to night, viewers watch darkness literally fall. But Torrell controls the lighting so carefully that the experience becomes surreal. You see darkness become tangible, almost solid. Torrell says, "I'm interested in the nature of light and how we perceive it. I'm working with light as a material, the way a sculptor works with stone. If light is a material, what is darkness? Its negative space equally essential to the sculpture." Film noir, that moody genre of crime dramas from the 1940s, is defined by its use of darkness. Characters hide in shadows. Light cuts across faces, revealing half while concealing half. Morality is ambiguous. The darkness isn't just atmosphere, it's the perfect visual metaphor for the moral ambiguity of the narratives. Director of photography John Alton, who pioneered the noir look, wrote a book called Painting with Light. The title is revealing darkness is the canvas, light is the paint. Let's get practical now. What happens when humans deliberately expose themselves to darkness? What do we learn? And what does this reveal about the nature of darkness itself? Sensory deprivation experiments began in the 1950s when psychologist John Lilly developed isolation. Tanks, lightless, soundless chambers filled with body temperature salt water where you float, deprived of all sensory input. Within hours, most subjects begin hallucinating. Without external input, the brain generates its own visual patterns, sounds, tactile sensations, even entire scenarios. Some people report mystical experiences, out-of-body sensations, or encounters with entities. What's happening? The brain is a prediction machine that constantly generates expectations about sensory input and compares them to actual input. When actual input drops to zero, the predictions run unchecked. You experience your brain's model of reality without reality to constrain it. Darkness reveals that your everyday experience is also a hallucination, just one constrained by sensory input. Take away the constraints, and the hallucination becomes obvious. Cave explorers who venture into deep caves report similar experiences. In complete darkness, the kind that exists hundreds of feet underground where no light has ever penetrated, time distorts. Minutes feel like hours. Your body's circadian rhythms become confused. Some cavers report feeling like they're no longer in normal reality. French cave explorer Michel Siffer conducted experiments living in caves for months at a time without time cues. His sleep-wake cycle drifted to about 25 hours. His perception of time passage was wildly inaccurate. What he thought was a month had been 2 months. Darkness disconnected him from the external temporal structure of the world. What does this mean? It means darkness doesn't just hide objects, it hides time itself. Light from the sun gives us day and night, our fundamental time structure. Without light, time becomes subjective, malleable, uncertain. In the early 2000s, Journalist Kira Salak spent a week in a Burmese Buddhist monastery, practicing darkness meditation, sitting in complete darkness for hours each day. She reported intense psychological experiences, confronting fear, experiencing ego dissolution, and ultimately a sense of profound peace. She wrote, "I learned that darkness is not empty. It's full of whatever we bring to it. This is the paradox. Physical darkness is absence, but experiential darkness is presence, the presence of your own mind's contents, usually hidden by external stimulation." Let's talk about blind individuals and their relationship with darkness. Do blind people experience darkness? This question has no single answer because blindness has many forms. People blind from birth report that they don't experience darkness. They experience nothing, which is different. Sighted people imagine blindness as like closing your eyes, but people who've never had sight have nothing to compare to. The absence of vision isn't darkness to them, it's just their normal state. People who lose sight after having vision often do experience darkness, at least initially. But many report that over time, the sensation of darkness fades. They simply live in a non-visual world, not a dark one. This reveals something crucial. Darkness is not an objective feature of the world. It's a perceptual category created by visual systems. No visual system means no darkness. Imagine a bat, which navigates primarily through echolocation. Does a bat experience darkness? Probably not in the way we do. When no light is present, the bat isn't deprived of its primary sense. It doesn't live in our visual world at all. To a bat, what we call darkness is just normal. This means darkness is species-specific. It's a human and other visually oriented animals concept, not a universal feature of reality. Let's consider an experiment you can do right now. Close your eyes for 1 minute. Really do it. What do you notice? First, you probably see phosphenes patterns of light caused by neural activity. Your visual system doesn't shut off just because no external light is present. Second, your other senses become more prominent. You hear sounds you weren't attending to. You feel the pressure of your body against your chair, the air on your skin. Darkness reveals that vision normally dominates awareness, suppressing other senses. Third, your mind might wander. Without visual stimulation anchoring attention to the external world, attention drifts inward to memories, plans, fantasies. Darkness is a doorway inward. Here's another experiment. Spend an evening without electric lights. Use only candles or firelight. Notice how your experience changes. Colors become muted. Depth perception becomes uncertain. The boundary between inside and outside blurs windows, become dark mirrors, not transparent views. But also notice how intimate candlelight feels. How faces become mysterious shadowed. How conversation deepens when you can't clearly see expressions. How the darkness outside feels present, almost like another person in the room. Our ancestors lived this way for hundreds of thousands of years. The experience of being a small circle of light, surrounded by vast darkness, was the human condition until very recently. Photographer Thierry Cohen created a stunning photo series where he combined city skylines with the starry skies that would be visible from those locations without light pollution. The images are shocking Manhattan under a sky blazing with the Milky Way, Tokyo beneath countless stars. These images make visceral what we've lost. Not just darkness itself, but what darkness reveals, our place in the cosmos. Light pollution doesn't just hide darkness, it hides the universe. Astronomers at the International Dark Sky Association are working to preserve natural darkness. They designate dark sky reserves, places protected from light pollution, where people can experience true night skies. Visiting these places is profound. Under genuinely dark skies, the stars don't twinkle distantly, they blaze. The Milky Way casts shadows. You feel the vastness of space. Darkness, paradoxically, makes the universe visible. Let's discuss the psychology of darkness adaptation. When you move from bright light to darkness, you're functionally blind for several minutes. Your rod cells, which detect dim light, need time to produce rhodopsin, the light-sensitive pigment. This process takes about 30 minutes to complete. But something interesting happens psychologically during this adaptation. Initially, you feel vulnerable, disoriented. But as your eyes adapt and you begin to see in the darkness, confidence returns. The darkness that seemed absolute reveals itself to be filled with forms and shapes. You learn that darkness is relative. You learn that your senses are more capable than you thought. You learn that fear of darkness is often fear of initial disorientation, not of darkness itself. This is a metaphor for life. What seems impossibly dark often contains more information than you initially perceive. Give it time. Let yourself adapt. What was terrifying becomes navigable. Let's project forward now. What is the future of darkness? How will artificial intelligence, advancing technology, and human civilization's evolution change our relationship with darkness? First, consider light pollution's trajectory. Currently, artificial light is increasing globally at about 2% per year. If this continues in a few generations, natural darkness might be completely eliminated from human experience in developed regions. Children will grow up never seeing a truly dark sky. What are the consequences? Beyond the ecological damage and health impacts we've discussed, there's a cultural and psychological dimension. If humans lose experiential contact with darkness, do we lose something essential to our humanity? Some scientists argue yes. Darkness shaped our evolution, our psychology, our spirituality. Eliminating it is an unprecedented change in the human condition, an experiment with unknown outcomes. But there's a counter-trend. The dark sky movement is growing. Communities are adopting lighting ordinances to reduce light pollution. People are deliberately seeking dark sky retreats, digital detox vacations, sensory deprivation experiences. Perhaps we're heading toward a bifurcation. Those who live in constant light and those who deliberately cultivate experiences of darkness. Now consider emerging technologies. We're developing artificial retinas, brain-computer interfaces, and augmented reality systems that could fundamentally change how we experience vision. Imagine augmented reality contact lenses that can amplify available light, making darkness effectively obsolete. You could see in pitch black as clearly as daylight. Darkness would cease to be a limitation. Or imagine neural implants that allow you to switch off your visual cortex voluntarily, experiencing true visual nothingness, not the darkness of closed eyes. Would this be liberation or loss? Futurist Ray Kurzweil predicts that by the 2030s, we'll be able to connect our brains directly to the cloud, expanding consciousness beyond biological limits. In such a future, would the concept of darkness even be meaningful? If you can access any visual information you want, if you can see in all electromagnetic frequencies simultaneously, if your perception is no longer bound by eyes and photons, what happens to darkness? It becomes a choice, not a condition. Darkness transforms from something that happens to you into something you opt into. But here's a disturbing thought. What if future humans lose the ability to process darkness? What if brains that develop with constant artificial visual input never learn the neural patterns for experiencing darkness? We might create a species that cannot experience darkness, not because darkness is eliminated from the environment, but because the perceptual category disappears from human consciousness. This would be the ultimate validation of our thesis. Darkness doesn't exist objectively. It's a perceptual and cognitive construct. Change the perceptual system, and darkness vanishes, not because you've added light, but because you've removed the framework that creates the experience of darkness. Let's consider space exploration. As humans move into space, we enter an environment of natural darkness far more profound than Earth. The darkness between stars is as close to absolute as naturally occurs. How will this affect human psychology? Early reports from astronauts describe the overview effect. Seeing Earth from space produces a cognitive shift, a sense of unity and perspective. But what about the darkness effect? Living surrounded by the cosmic void? Some science fiction has explored this. Arthur C. Clarke's 2001, A Space Odyssey, depicts isolation and existential dread in the darkness of space. The film is famous for long, silent sequences showing spacecraft moving through darkness. The darkness becomes a character, a presence. Future spacefaring humans might develop new relationships with darkness, seeing it not as absence, but as the natural state of most of the universe. Earth's brightly lit surface might come to seem like the anomaly, or perhaps will light up space. The Kardashev scale, proposed by Soviet astronomer Nikolai Kardashev, categorizes civilizations by energy use. A Type 2 civilization harnesses the total output of its star. A Type 3 harnesses its entire galaxy. What would a Type 2 civilization look like? Imagine a Dyson sphere structure that completely surrounds a star, capturing all its light. From the outside, the star would appear dark. The civilization would be living inside, bathed in light, while the external universe experiences darkness. A sufficiently advanced civilization might darken the entire universe from an external perspective while maximizing light internally. Darkness and light would be completely redistributed. Now let's get really speculative. Some physicists have proposed that our universe might be a simulation running on a substrate of computational processes. If this is true, what is darkness in a simulation? Darkness would be pixels or voxels assigned low values for light intensity. It wouldn't be the absence of anything. It would be specific values in a data structure. Darkness would have exactly the same ontological status as light. Both would be information patterns in the simulation. In this view, the question, does darkness exist, becomes, do low values in a light intensity data field exist? The answer is obviously yes. Darkness and light would be equally real as information states. But here's where it gets wild. In a simulation, you could have impossible darkness. Regions where light intensity has negative values, or imaginary values, or values that don't correspond to anything in physical reality. The simulation could violate the laws of physics we observe, because those laws might just be rules of the simulation, not fundamental constraints. Future civilizations with control over simulation parameters could create forms of darkness and light that are literally inconceivable to us perceptual states with no analog in our experience. Let's consider artificial intelligence and machine vision. AI systems see very differently from humans. They analyze images as data arrays, extracting features and patterns. When an AI processes a completely black image, what is it experiencing? Nothing resembling our experience of darkness. It's processing an array of zeros or very low values. There's no phenomenology, no what it's like to be the AI seeing darkness. Or is there? This is the hard problem of consciousness. We don't know if AI systems have subjective experiences at all. If they do, what would their experience of a low light intensity data array be like? Would they have something analogous to our darkness experience, or something completely alien? Quantum computing introduces another twist. Quantum computers use qubits that exist in superposition simultaneously, 0 and 1, until measured. Imagine a quantum visual system that could represent a region as simultaneously light and dark until observed. Schrödinger's darkness both present and absent until you look. This sounds like science fiction, But quantum biology is discovering that quantum effects play roles in photosynthesis, bird navigation, and possibly even consciousness. It's not impossible that quantum superposition is involved in perception in ways we don't yet understand. Perhaps darkness and light don't have definite values until consciousness collapses the quantum wave function through observation. Let's bring this back to Earth with a near-future scenario. Gene editing and synthetic biology might allow us to modify human eyes. We could add additional photoreceptors for infrared or ultraviolet. We could enhance low light sensitivity 100-fold. Humans with these modifications would experience a different world. What we call darkness, they'd see as dimly lit. They'd perceive colors we can't imagine. The experiential category of darkness would shift. We might have multiple human subspecies with different relationships to darkness. Some who see far into infrared and never experience true darkness. Others who've deliberately preserved natural vision and still value darkness. This raises ethical questions. Is it right to modify humans to eliminate darkness from their experience? Are we losing something important? Or is this just another step in human evolution, like using fire and electric light before it? There's no obvious answer, but the question reveals how fundamental darkness is to human identity. Changing our relationship with darkness changes what it means to be human. Here's a final future scenario that brings everything full circle. The heat death of the universe. Trillions of years from now, all stars will burn out, all black holes will evaporate, and the universe will reach maximum entropy, a state of uniform, cold darkness. But as we discussed earlier, even this final darkness contains quantum fluctuations. Given infinite time, these fluctuations could spontaneously create new structures, new universes, new Big Bangs. The physicist Roger Penrose has proposed a cosmological model called conformal cyclic cosmology, where the universe goes through infinite cycles. Each cycle ends in heat, death, darkness, and somehow this darkness gives birth to the next cycle's Big Bang light. In this view, darkness isn't the end. It's the transition between universes. Darkness is the creative void from which everything emerges and to which everything returns eternally. The future of darkness is the future of existence itself. They're inseparable. And perhaps this is the ultimate answer to our question. Does darkness exist? Not as a thing in itself, but as the boundary condition of existence, the frame that makes light meaningful, the silence that makes sound audible, the space that makes matter possible. Darkness is the canvas of reality. Now let's bring all of this back to you, personally. How does understanding that darkness doesn't exist, or exists only as absence, change how you live your life? First, let's address fear. If you're afraid of darkness, you're afraid of something that isn't there. But does knowing this eliminate the fear? Probably not completely. Fear of darkness is hardwired through evolution and reinforced through culture. Intellectual understanding doesn't automatically rewire emotion, but it can help. When you're in darkness and feel fear rising, you can remind yourself, I'm not afraid of what's here. I'm afraid of what might be here. The fear is about uncertainty, not about darkness itself. This reframing is powerful. Uncertainty you can address by gathering information, by preparing, by accepting what you can't control. But fear of darkness as a malevolent force? That's fighting a phantom. Think of it like this. Imagine you're afraid of ghosts. Then you learn that ghosts definitely don't exist. It's been scientifically proven beyond doubt. You might still feel nervous in supposedly haunted places, but the intellectual certainty changes something. You can talk yourself down because you know your fear has no actual object. Understanding that darkness is absence, not presence, does the same thing. The monster in the darkness is never the darkness itself. Now let's talk about metaphor in your life. We use light and darkness metaphorically constantly. I'm in a dark place. Things are looking brighter. The situation is grim. A glimmer of hope. These aren't just poetic flourishes. They shape how you think about your emotional and psychological states. Depression is often described as darkness, happiness as light or brightness. This metaphor structures your entire emotional landscape. But what if you applied our understanding to these metaphors? Depression isn't the presence of something dark. It's the absence of something energy, motivation, meaning, hope. It's not a thing attacking you. It's the lack of things that usually sustain you. This reframing suggests different approaches to mental health. Instead of fighting the darkness of depression, you might focus on adding light, slowly rebuilding the things that are absent. Small sources of meaning, tiny increases in activity, gradual reconnections with people. The metaphor of light and darkness, understood properly, becomes therapeutic. Let's apply this to knowledge and ignorance. We say someone is in the dark when they lack information. Shedding light on something means explaining it. Enlightenment is the ultimate knowledge. But ignorance, like darkness, isn't a thing. It's the absence of knowledge. You can't fight ignorance directly. You can only add knowledge. And just as a single candle dramatically changes a dark room, a single crucial piece of information can dramatically change your understanding. This has practical implications. When you're confused about something, you're not lacking the ability to understand. You're lacking specific information. The confusion isn't a deficiency in you. It's an absence in your information landscape. Find the missing piece, and clarity emerges. Now consider relationships. We talk about people's dark sides, hidden aspects of personality, usually negative ones. Carl Jung's shadow concept, which we discussed earlier, treats this darkness as something to be integrated, not eliminated. If you apply our framework, your dark side isn't a separate entity. It's the parts of yourself that are absent from your conscious self-image, the anger you don't acknowledge, the desires you don't accept, the fears you won't face. Integrating the shadow means making the absent present, bringing what's hidden into awareness, not adding something foreign, but acknowledging what was already there but unseen. This is deeply psychological work, but understanding darkness as absence makes it less frightening. You're not confronting a monster. You're illuminating corners of yourself that have been in shadow. Let's talk about death. In many cultures, death is associated with darkness, going into the darkness at the end. If death is like darkness, and darkness is absence, what does this mean? It suggests death isn't a place or state you enter. It's the absence of life. There's no you in darkness experiencing darkness. There's just absence. No experience at all. This might be comforting or terrifying, depending on your perspective. Comforting because there's no suffering in absence. Terrifying because there's no continuation of consciousness. But it clarifies what's at stake. The question isn't, what's it like to be dead? Any more than, what's it like to be darkness? Both questions assume being where there isn't any. The question is, how do you live given that absence awaits? Does the temporary nature of light make it more precious? Does the inevitability of darkness make the present moment more vivid? Many people report that confronting mortality, truly accepting that their consciousness will end, makes life more meaningful, not less. The darkness at the end gives the light of life definition, boundaries, shape. Let's discuss attention and distraction. Modern life is full of light, literal light from screens, metaphorical light from constant information, entertainment, stimulation. When do you experience darkness sensory, informational, attentional? Probably rarely. You might be suffering from darkness deficiency, lack of unstructured, unstimulated time when your mind can wander in its own darkness. This matters because creativity, insight, and deep thinking often emerge from internal darkness times when external input is minimal and you're forced to generate from within. Constant light, literal and metaphorical, prevents this. Try this practice. Spend time regularly in deliberate darkness. Close your eyes. Turn off screens. Sit in actual darkness. Don't fill the void with podcasts or music. Just ... Be in the darkness. Initially, it might be uncomfortable. Your mind might race. You might feel anxious or bored. But if you persist, something interesting happens. Thoughts you didn't know you had emerge. Insights bubble up. Creative connections form. The darkness creates space for your mind to speak to itself. From a practical standpoint, understanding darkness also means understanding contrast. Anything meaningful in life exists in contrast to its absence. Joy is meaningful because sadness exists. Success matters because failure is possible. Connection is precious because loneliness is real. If you had constant light, you'd stop noticing it. Similarly, if you had constant happiness, it would cease to feel like happiness. It would just be your baseline. The darkness of negative experiences isn't the enemy of good life. It's what makes the good parts perceivable. This doesn't mean seeking suffering. It means accepting that the full range of human experience, light and darkness, is what creates a meaningful life. Trying to eliminate all darkness is like trying to have a photograph with no shadows. You can't. And if you could, it would be flat, dull, meaningless. Here's a practical exercise. Tonight, before sleep, spend 5 minutes in complete darkness, or as complete as you can manage. Don't use your phone. Don't turn on a nightlight. Just sit with the darkness. Notice your emotional response. Notice what thoughts arise. Notice whether your body relaxes or tenses. Notice whether the darkness feels threatening, peaceful, neutral, or something else. Then notice the darkness isn't doing anything to you. It's not acting on you. Everything you're experiencing is your response to absence. You're meeting yourself in the darkness. This is profound. Darkness is a mirror. In the absence of external stimuli, you encounter yourself directly. We've journeyed far together, from physics to philosophy, from neuroscience to mythology, from quantum mechanics to personal psychology. Now let's synthesize everything into a coherent answer to our original question. Does darkness really exist, or is it just the absence of light? The answer, like most profound answers, is both simple and complex. Darkness does not exist as a physical entity, but it absolutely exists as an experience, a concept, and a necessity. Let me break this down into levels of reality. Physical level. Darkness is simply the absence of photons in the visible spectrum. It has no particles, no energy, no independent existence. You cannot create darkness. You can only remove light. You cannot transmit darkness. You can only block light. Darkness is to light what silence is to sound, what vacuum is to matter, what zero is to numbers. At this level, the answer is clear. Darkness doesn't exist. It's nothing pretending to be something. Perceptual level. Darkness exists as a real, vivid experience generated by your nervous system when visual input drops below a threshold. The experience has neural correlates, physiological responses, and subjective qualia. When you experience darkness, something is happening in your brain-specific patterns of neural activity that are different from the patterns during normal vision. At this level, darkness exists as surely as pain exists, as colors exist, as consciousness itself exists. It's subjectively real. Conceptual level. Darkness exists as a category of human thought, embedded in language, culture, and psychology. It's a framework we use to organize experience and communicate about the world. Try to eliminate the concept of darkness from your mind. You can't. Even knowing it's just absence, you still think with and through the concept. At this level, darkness exists as a social and cognitive reality that shapes human life. Metaphysical level. Darkness might be understood as potentiality, the ground state from which manifestation emerges. In quantum field theory, the vacuum state isn't empty nothingness. It's a field of potential from which particles arise. In metaphysics across cultures, the void or darkness is often seen as the source, the womb, the fundament. At this level, darkness exists not as absence, but as the most fundamental presence being itself before it takes specific form. So which level is real? All of them. Reality isn't single-layered. Physical, perceptual, conceptual, and metaphysical layers all exist simultaneously, and darkness has different status at each level. This multi-layered understanding resolves the paradox. Darkness doesn't exist physically, but does exist experientially and conceptually. Both statements are true from their respective frameworks. Now let's extract the deeper implications. Implication 1. Absence can be as powerful as presence. The fact that darkness doesn't exist physically doesn't make it powerless. Throughout history, darkness has shaped human behavior, culture, and psychology as much as light has, sometimes more. The absence of something can drive action more powerfully than the presence of something. Think about hunger. Hunger is the absence of satiation, yet it drives massive portions of human activity. Or loneliness, the absence of connection, which shapes behavior profoundly. Or existential anxiety, awareness of the absence of inherent meaning, which drives some people to religion, others to philosophy, others to creative achievement. Absence has power precisely because we're designed to notice it and respond to it. Implication 2. Opposites are often not symmetrical. We think of light and darkness as opposites, as equal forces in opposition, but they're not symmetrical. Light has existence, energy, properties. Darkness has none of these. It's simply what remains when light is absent. This asymmetry appears throughout reality. Heat and cold. Cold is absence of molecular motion. Sound and silence. Silence is absence of sound waves. Being and non-being. Non-being is absence of being. Many apparent dualities are actually asymmetrical. One pole has positive existence. The other is its absence. Understanding this changes how you approach these dualities. Implication 3. Perception is constructive, not passive. Your experience of darkness reveals that perception isn't just receiving data from the world. It's your brain actively constructing experience, including the experience of absence. You don't just fail to see in darkness. You actively experience darkness as a vivid presence. This means all your perceptions are constructed. Color doesn't exist in light waves. It's constructed by your brain. Solidity doesn't exist in atoms, which are mostly empty space. It's constructed by your brain. Reality as you experience it is a user interface, not a direct readout of objective physics. Darkness teaches you that your entire experienced world is a construct. Implication 4. Context creates meaning. Light only has meaning in contrast to darkness. But here's what's profound. You don't need to fight the darkness. You can't eliminate it, and you shouldn't want to. The darkness is the background that makes your light visible. It's the silence that makes your voice audible. It's the absence that makes your presence meaningful. Your task isn't to banish darkness, but to create light and to know when to rest in darkness. Let me offer you a final framework for living with this understanding. Create light actively. Light doesn't emerge from wishing. It requires energy, effort, structure. Whether literal light, making fire, turning on lamps, or metaphorical light, creating meaning, sharing knowledge, fostering connection, you must actively bring it into being. Accept darkness gracefully. Darkness will come. Night will fall. Knowledge will reach its limits. Relationships will end. Life will end. Fighting these inevitable darknesses causes suffering. Accepting them allows peace. Appreciate contrast. The interplay of light and darkness creates beauty. Don't flatten your life into uniform brightness. Allow rhythm, activity, and rest, community, and solitude, doing and being. The variations create meaning. Cultivate inner light. External circumstances will fluctuate between light and darkness. But you can develop internal sources of light resilience, meaning, purpose, love that persist even when external darkness is overwhelming. Explore darkness consciously. Don't just endure darkness, investigate it. In sensory darkness, you discover interior dimensions. In intellectual darkness, not knowing, you discover wonder. In psychological darkness, shadow, you discover wholeness. Share light generously. Light shared multiplies. Knowledge shared increases. Love given grows. Unlike material goods, light isn't diminished by sharing. Be a source of light for others. Remember impermanence. Both light and darkness pass. The darkest night gives way to dawn. The brightest day fades to dusk. Nothing is permanent. This could be depressing or liberating. Choose liberation. I want you to try something in the coming days. Tonight or soon, spend time in deliberate darkness. Turn off all lights. Sit comfortably. Close your eyes or leave them open. It doesn't matter in true darkness. At first, notice your response. Anxiety? Peace? Boredom? Curiosity? Don't judge whatever arises. Just notice. Then, notice the darkness itself. Not conceptually, but experientially. What does it actually feel like? Notice the phosphenes, the swirling patterns, the sensations. Notice how your other senses heighten. Notice sounds you'd normally ignore. Notice the feeling of your breath, your heartbeat. Notice that in darkness, you become more aware of yourself. The external world fades, and your interiority becomes prominent. Sit with this. Let yourself just be in the darkness, without trying to fill it or escape it. If you can maintain this for even 10 or 15 minutes, something interesting might happen. The darkness stops feeling like absence and starts feeling like presence, not of something external, but of your own awareness encountering itself. This is the secret hidden in darkness. It's a meeting place with your own consciousness. The mystics knew this. The contemplatives knew this. The artists knew this. Darkness is where you discover that you're not just a passive receiver of sensory input. You're a generator of experience, a source of awareness, a light unto yourself. Let me share one final image that brings everything together. Imagine you're looking at a night sky full of stars. Each star is light that has traveled for years, decades, centuries, or millennia to reach your eyes. The light from distant stars left before you were born traveled through the darkness of space and arrived at this precise moment to enter your eyes and create your experience of a starry sky. But the stars are just tiny points. Most of what you see is darkness. The vast, deep darkness between the stars? Which is more important, the stars or the darkness? Neither. Both. They're inseparable. The stars need the darkness to be visible. The darkness needs the stars to be perceivable. Without both, there is no starry sky. Your life is like this. Points of light, moments of joy, insight, connection, achievement, against a background of ordinary darkness routine, the unknown, rest, death. Neither the lights nor the darkness alone would create a meaningful life. Together, they create the constellation of your existence. You are not just the points of light. You are the entire field, light and darkness together. And here's the ultimate secret. The one experiencing all of this, the awareness reading these words right now, the consciousness that's been following this journey, that awareness is neither light nor darkness. It's what makes both perceptible. You are the space in which light and darkness appear. You are the awareness in which presence and absence both arise. You are not reducible to either. In the deepest sense, you are not in the universe. The universe, with all its light and darkness, is in you. This isn't mystical poetry. It's the literal truth of experience. The universe you know exists entirely within your consciousness. The light and darkness you've been pondering are experiences arising in awareness. That awareness, you, is the ground of everything you've ever known. So does darkness exist? Yes and no. No as a physical entity. Yes as an experience. But more fundamentally, both light and darkness are contents of awareness, and that awareness is what you truly are. You are neither the light nor the darkness. You are that which knows both. And in knowing this, you're free. Free from fearing darkness as if it were an enemy. Free from clinging to light as if it were salvation. Free to dance with both, to create with both, to be fully alive in a universe that is both luminous and dark. This is what the question was really asking all along. Not, does darkness exist? But what am I? And the answer is, you are the knowing, the seeing, the awareness itself. You are the light of consciousness in which all light and darkness appear. And that light never goes out. Thank you for taking this journey with me. If this expanded your understanding, challenged your assumptions, or shifted your perspective, please hit that like button and subscribe. This is the kind of deep exploration we do, here taking questions that seem simple and discovering their doorways to profound understanding. Drop a comment and tell me, what's your relationship with darkness now? How has this changed your perspective? And what other questions about reality do you want to explore together? Remember, every time you experience darkness, you're experiencing one of the universe's great paradoxes, something that doesn't exist having tremendous power. Let that remind you that reality is stranger, deeper, and more wonderful than it first appears. Until next time, keep questioning, keep exploring, and keep seeking the light in yourself and in the darkness.